Hey, good morning, everyone. Today's lesson is a quick review of trigonometry from some of our maybe Math 10C or even Math 9. One of the things that we want to review quickly is how do you name your triangles? Very conventional way is to always call the right angle C, and then the other two angles can be A and B. We like to use the uppercase letters for our angles, and then how we name the sides is we look at opposite of big C, we're going to put a little c. Opposite of big A, we're going to put little a. And opposite of big B, we're going to put little b. So that's a very traditional way of labeling the triangle. And one of the sides that we always like to identify is the hypotenuse as well. So when it comes time for labeling triangles, uh, label your hypotenuse first. Always label it opposite the right angle. And then traditionally, you can use C for the 90-degree angle, A and B for the other two sides. If we name our triangle with that format, then the formula is a squared plus b squared equals c squared. That works really well for finding the hypotenuse. And for finding one of the other missing sides, it'd be c squared minus b squared or c squared minus a squared would also work to find a missing side. So the main thing here is that if you're doing this, make sure C is your hypotenuse. So we want to do a couple of examples, one find the hypotenuse and one finding the other side. You can name the hypotenuse C, you can name it X, it doesn't matter. Traditionally, again, if you want to use C because it matches your formula, you're going to use A squared plus B squared equals C squared. Your two sides, doesn't matter which one's A, which one's B, but they're the smaller side, so the two little squares add up to equal the big square. So if I change my C for an X, I get 5 squared plus 3.5 squared equals X squared. Grabbing our calculators, 5 times 5 is 25. 3.5 times 3.5 is 12.25 equals X squared. Add those two values together. 37.25 is X squared. And the opposite of squaring is the square root. Quite often we ask you to find the length of the side to nearest tenths. In this case, we can even go, let's go nearest tenth. We have one decimal place in our question, or for you guys in science, we have two significant digits. So we can say the length is 6.1 meters. That's a reasonable answer as well, because the hypotenuse should be longer than the other two sides. So one side is 5, one side is 3.5. Hypotenuse 6.1 makes sense. So a quick review of a squared plus b squared equals c squared when you're solving for the hypotenuse. Let's do the second example, and let's solve for the non-hypotenuse side. You can call it a or b or x. Let's say this is b, or later on we'll call it x. So if I'm going to solve for b squared, I want to go c squared minus a squared. And whether it's c squared minus a squared equals b squared or b squared equals c squared minus a squared, they have the same meaning. Again, if we put in x instead of b, the hypotenuse has to be the largest side. So this is the 245 squared and the 185 squared. Again, grabbing our calculators, 245 squared is 34,225. I want to subtract 185 squared, which is, I've given us some bad numbers here. I'm just going to erase this for a second. 245 squared looks like it's going to be 60,025. And the 185 squared is the 34,225. So I want to subtract those two values. And again, the reason we're subtracting them is we're going to find a shorter side. So this equals 25,800. Opposite of squaring is to square root. So x equals the square root of 25,800. So x equals 160.6, and these are in centimeters. Again, that's a reasonable answer. the hypotenuse has to be longer than the other side. So if the hypotenuse is 245, having a side of 160.6 or 161 centimeters makes sense. So that was a real quick review of how to find either a missing side or a missing hypotenuse when you know two sides of the triangle. Let's go to page 2, and before we start using sine, cosine, and tangent, three ratios that are on your calculator, let's again look at labeling our triangle. And I drew a second triangle on here. You're going to have to draw your own second triangle. Let's still call the right angle C, and let's go A, and let's go B. And now we just want to talk about angle A. So let's circle A or do something with A to identify this is the angle that we're talking about. So relative to angle A, we want to be able to name hypotenuse. So hypotenuse doesn't matter where A is, it matters where the C is. Hypotenuse is always away from the C. So that's something that I always name first, my hypotenuse. Then I want to talk about the side that is away from angle A. So the side away from angle A is opposite of angle A. I like to put the A there as well because it gives me a reference point for what I'm talking about. And then the side that's left is the side that is adjacent to angle A. So we want to make sure we can name our triangles hypotenuse, opposite, and adjacent. Let's name A, B, C, but let's talk about B this time. So again, let's still call C, A, and B, but let's talk about B. So we again want to name our three sides. Always start with the hypotenuse, the side that is opposite the right angle. Always start there. Second side to look at is the side that is opposite of angle B. So all the way over here is opposite of angle B. And this again is why I like to put the B in here, because opposite B means the same thing as adjacent to A. So we have to try and help keep things clear for ourselves. So putting a letter in, it helps us identify that. And then the side that's missing is the side that is adjacent to angle B. So most important when we're looking at trying to use sine, cosine, and tangent is we need to know that we can name and label our triangles hypotenuse, opposite, and adjacent. And the reason we use those is on our calculators we have three ratios. We have a sine ratio, a cosine ratio, and a tangent ratio. And sine ratio is opposite over hypotenuse. So again, when you talk about scale diagrams, as long as you have a specific angle, the sine ratio of 20 degrees is always going to be a specific ratio, specific decimal. Cosine ratio, tangent ratio. How do you remember those? Sometimes we talk to you in grade 10 about using the acronym SOHCAHTOA, SOHCAHTOA, something along those lines. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Then we have two different skill sets in working with sine, cosine, and tangent. We have the skill set of finding sides, and we have the skill set of finding angles. And our calculators have kind of a forwards and backwards. They have a forwards and reverse. Finding sides is like driving your car forwards. Finding angles is like driving your car backwards. So the thing we want to look at is identify the sides of your triangle relative to the angle given to you. So let's start off by maybe even throwing the 90-degree angle in here. So identify the right angles. So we have a right angle, which means x becomes my hypotenuse. So I like to name my hypotenuse. We are talking about the angle up here. We're talking about the angle of 35 degrees. The side down here in the bottom is the opposite side. So again, if I travel away from 35, 35 is projecting onto the opposite side. The side 12 then becomes the side that is adjacent. So now you need to be able to kind of do some problem solving. Look at the information that you're working with. You're working with 35 degrees, you're working with adjacent, and you're working with hypotenuse. Sine, cosine, or tangent. That's what we have to decide. sine, cosine, or tangent, adjacent, and hypotenuse. That then becomes the cosine ratio. So if you go back up top, cosine of theta is adjacent over hypotenuse. So I'm going to actually write that out. Cosine of theta equals adjacent over hypotenuse. And then I'm going to start putting in the numbers that I know for this specific problem. Instead of writing theta, I'm going to say cosine of 35 degrees. Instead of saying adjacent, I'm going to put 12 in because it's 12 centimeters. And instead of putting hypotenuse, I'm going to put x. And I don't really need that degree symbol in here. I just need to know that I'm actually working with degrees. So this is a very important thing at this point in time. We just talked about the word degrees there. We have to make sure that our calculator is actually in degree mode. If it's not in degree mode, if you're in something called radian mode or gradient mode, your calculator has a different way of calculating the ratio. So cos of 35 degrees. There's a couple of things you can do here. One is you can kind of use your cross multiplying skills and solve for x. So if you think about this as being a cross multiplying question, then we should make this like cos of 35 over 1. So you have a ratio equals a ratio. You have a top and a top and a bottom and a bottom. If you consider cross multiplying, whoa, that was crazy. If you consider cross multiplying and you want to solve for x, it's like the x and the cos 35 trade places when you're cross multiplying. So it's top times bottom, or it's bottom times top, whichever way you look at it. But a cross multiplying ratio allows us to solve for x as 12 divided by the cosine ratio of 35. And then just type this into your calculator because it is really about working forwards on your calculator. So if you go x equals 12 divided by cosine, some of your calculators will put a bracket in here. So if that happens, that's okay. Cos of 35, we should always just close that bracket. If your calculator didn't put a bracket in there, that's fine. But it's just 12 divided by cos of 35. And then angles, quite often when we're solving angles, we just find angles to the nearest degree. But this is not an angle, my bad. So let's still solve this for one decimal place. 12 divided by cos of 35. And I have an answer of 14.6. So look at the question that we had. We were solving for the hypotenuse. 14.6 is a reasonable answer for the hypotenuse because it's longer than the side of 12. Hypotenuse has to be longer than the other sides. So it makes sense that it's bigger than 12 centimeters. So again, reviewing this, we had adjacent hypotenuse, told us the cosine ratio. We write the ratio, we put the numbers in, we can cross multiply, we can solve. X equals 14.6. Let's do our second example. So our second example, again, we said what we want to do first of all is identify where the right angle is. So the right angle in this one is going to be this top corner. So let's put the 90-degree angle in there. As soon as we put 90 degrees in there, let's label our hypotenuse. Let's talk about the angle that's given to us at 48 degrees. So where we have our x now is the side that's opposite of 48 degrees. And I can even put 48 in here just to kind of help me identify I'm talking about 48. And then on the missing side, not the missing side, the 15-meter side, this is the adjacent side, or adjacent to 48. So now again, I want to figure out what ratio am I talking about. I've got an angle of 48 degrees. I'm talking about an opposite side, and I'm talking about adjacent side. I'll look at my ratios if I'm not sure which one I'm supposed to use. Opposite hypotenuse, no, so I don't have hypotenuse. Adjacent hypotenuse, no, I don't have hypotenuse. Opposite and adjacent. That tells me I'm going to write the tangent ratio because I'm talking about an angle. I'm talking about the side opposite the angle. I'm talking about the side adjacent to the angle. So I'm going to start off with my tangent ratio is opposite over adjacent. Let's put numbers in. So instead of theta, let's write tangent 48. Instead of opposite, I'm going to put x because that's the length we're going to solve for. And then the bottom number in this example is 15. Again, if I want to treat this like it's a cross multiplying question, I have tangent 48. I want to put that over 1, so now I have a top number, bottom number equals a top number, bottom number. I'm going to cross multiply. This time, if I cross multiply the x's by itself already, so my answer just becomes 15 times by, I can put a little dot here, 15 times by tangent 48. So this basically becomes put the calculations straight into your calculator. So 15 times tangent 48, and if I do that, I get x equals 16.7. And do I have units in this one? Looks like I have meters. So 16.7 meters is my answer. And that looks like a pretty reasonable answer as well. One of my sides is 15. The triangle doesn't look like the sides are a whole lot different in their length. So the bottom one, being the hypotenuse, would be the biggest, but x being 16.7 makes sense. So that's how you, again, as we didn't do an example with the sine ratio in terms of finding a side, but it'd be the same thing. If you were working with opposite and hypotenuse, you'd have to use the sine ratio. So we said we have a couple of skills. We have a skill of finding sides, and we have a skill of finding angles. So I put my angle questions on the next page. So I'm just going to click there, and we can go through the exact same kind of process now, figure out what information is given to us, figure out what ratio we're going to work with. So again, identify the right angle. My hypotenuse is away from my right angle. I'm talking about finding angle x. So if I walk away from x, I know that this side here is opposite, and that leaves 18 as the adjacent. So label the triangle first. It takes a couple of seconds to do that. Then there's less confusion in terms of figuring out your ratio. It's like solving a problem. I want to now work with my 18 centimeters, my angle, and my 22 centimeters. So just like the last question where we found the side using tangent ratio, we're now going to find the angle using tangent ratio. So the formula is tangent theta is opposite over adjacent. Great way to start the problem. Gives us something to put our numbers into. Instead of writing theta, I'm actually going to write tan of x this time. And the opposite is 22, and the adjacent is 18. So as we can see, this is different than finding a side. We're going to find the angle. The x value is attached to the tangent ratio. So how do we change this then in regards to solving for x? This is where you have your calculator work backwards. So if I'm going to solve for my angle, I want to find x degrees, I need to take my tangent ratio and tell my calculator I want to work backwards. So this is where you use either your inverse button or your shift button, but you have to tell your calculator that you want to find the angle. So tan minus 1 will probably pop up on your calculator. If you go shift or second or inverse, I think most of us probably have a second button, second tan, or shift tan, one of those two things. Shift tan should give us tan minus 1. What goes in the brackets is still 22 divided by 18. If you want to change that to a decimal, you can. So if we go tangent ratio, and if we go 22 divided by 18, and write that down to a few decimal places, that's 1.222. So 1.222, or 22 divided by 18 without doing that step. And if we take this and make sure we're still in degree mode, we get an angle of 51 degrees. So that missing angle in our triangle is 51 degrees. Again, that's actually a reasonable answer. Because 22 is larger than 18, the angle we're finding is going to be more than half of 90 degrees, which those other two angles will add up to. Okay, so working backwards, or working to find an angle, still the same steps. Write the ratio, put your numbers in, but this time it's second tangent or shift tangent, and then round things off. Our last example, before you get to work on some of these questions on your own, again, we want to solve for an angle. So let's label the right angle. Always start with the right angle. The hypotenuse, we're talking about an angle here, so the side across the field is the opposite, which means the side that we don't work with this time is going to be the adjacent. So I want to find an angle. I want to work with the hypotenuse, and I want to work with the opposite. Those are the sides that I have numbers for. So my ratio then is opposite over hypotenuse is sine of theta is opposite over hypotenuse. So again, kind of like solving a puzzle, we need to know what is our first step going to be. Then after we have that information, we start going step by step or piece by piece and working things out. So sine of x, opposite is 125. Hypotenuse is 145. Because I'm going to solve for an angle, the same way we did the tangent question, we're going to tell our calculator to go backwards. So this is a step that we should be showing. I want my calculator to find an angle for me. It will put the bracket in there for you. If you want to put 125 over 145, if you want to change that to a decimal, either way, it's going to give you the same answer. Again, as long as we're in degree mode, and we're going to round this off to a nearest degree, this is 60 degrees. So that's a very quick review of sine, cosine, and tangent, as well as working with Pythagoras. A squared plus b squared equals c squared.